Hello friends, welcome to our channel HT and LT Electrical and Electronics Engineering. In here I am going to discuss about circuit breaker part 3. In the previous part 1 and part 2 I have discussed about operation of different circuit breakers briefly. Let's start the circuit breaker part 3. The fault across three phases and between three phases and earth are symmetrical fault. The symmetrical short circuits produces the maximum amount of fault current in the system. The symmetrical short circuit current determines the rupturing or breaking capacity of the circuit breaker. How to calculate the short circuit MVA? Here we are going to calculate the rupturing or breaking capacity of a switch gear in case of a three-phase symmetrical fault. This specification is important to determine the size of the circuit breaker, to deal with the short circuit current, and to ensure that the associated apparatus can withstand the thermal and magnetic conditions which arise due to flow of heavy fault current. The short circuit MVA can be found out if the capacities of generator, transformer and their percentage reactance are known. What is percentage reactance? The percentage reactance of a circuit is defined as the percentage of the total phase voltage dropped in the circuit when full load current is flowing. Here is percentage reactance, percentage X is equal to Ix divided by V into 100. I is equal to full load current, V is equal to phase voltage, X is equal to reactance in ohms per phase. Okay, next. Thus, percentage reactance of a transformer is the percentage of phase voltage drop when full load current flows through it. If X is the percentage reactance in the circuit, then short circuit current is given by ISC. ISC is equal to I into 100 by percentage reactance. The short circuit MVA and current is determined mainly by the reactances of the alternator, transformers and lines up to the point of fault. The resistance is generally neglected, which is very small compared to reactance. Example: if the percentage reactance of an transformer is 20%, then the full load current is 50 ampere. The full load current is 50 ampere. Then the short circuit current will be 50 into 100 by 20 is equal to 250 ampere. When only the transformer is in the circuit. When only the transformer is in the circuit. Short circuit MVA calculation. For short circuit calculation, the following procedure are maintained. First, all reactances are converted into percentage reactance. If not given in percentage values, the percentage reactance is given by percentage reactance is equal to Ix by V into 100, where X is the reactance, B the rated voltage and I the full load current. Second, a single line diagram showing the kVA ratings and the percentage reactances of all the equipments and lines is drawn. Okay, next. If there are various equipment, e.g. generators, transformers, etc. in the circuit with different ratings, an arbitrary rating known as base kVA is chosen and all percentage reactances are converted to equivalent values on the base kVA, which is determined by the formula. Percentage reactance on base kVA is equal to equipment percentage reactance into base kVA divided by equipment kVA. Fourth, the network is now redrawn in the form of reactance diagram for clarity, and the equivalent reactance of the network is found by the method as adopted for series parallel reactances. The short circuit capacity is then found out from the formula. Short circuit MVA is equal to base kVA divided by 1000 into 100 by percentage equivalent reactance X, where X is the equivalent percentage reactance of the network. Okay, next. Here is an example, example 1. Here is a generator, 2000 kVA, 8% percentage reactance of 11 kV generator, and here 2000 kVA 6% transformer, 11 by 6.6 kV transformer. Here the two fault point F1 and F2. In the picture above, a 11 kV, 2000 kVA and 8% reactance generator supply power to 11 by 6.6 kV, 2000 kVA and 6% reactance transformer. In the system, if three-phase fault occurs at position F1 and F2, then what will be the short circuit current? Here is the answer. Assume base kVA 2000 kVA. Here all the kVA rating 2000 kVA. No problem. So percentage reactance of generator 8%, percentage reactance of transformer 6%, percentage reactance up to fault F1 8%. So the short circuit MVA, according to the formula, short circuit MVA 2000 by 1000 into 100 by 8 is equal to 25 MVA. System voltage at F1 is equal to 11 kV. Here is 11 kV system voltage. So short circuit current ISC is equal to 25 into 1000 divided by root 3 into 11 is equal to 1312 ampere. Okay, next. Equivalent reactance up to F2 percentage XC is equal to 8 plus 6, 14%. So the short circuit MVA 2000 by 1000, 100 by into 100 by 14 is equal to 14.28 MVA. The system voltage at F1 position 6.6 kV. So short circuit current ISC is equal to 14.28 into 1000 divided by root 3 into 6.6 is equal to 1250 ampere. So the value of the transformer secondary bus is 14.28 MVA or 1.25 kiloampere. In this portion, the supply voltage is 11 kV, and in this portion, supply voltage is 6.6 kV. 6.6 kV, and here is 11 kV. Okay, next. Here is another example, example 2. There are two generators, G1, G2, One is 10,000 kVA, 11 kV, and second one in 5,000 kVA, 11 kV, and this is 7.5% percentage reactance, and this percentage reactance is 10%. They are supplied to a 5,000 kVA 600 5,000 kVA 6% percentage reactance and 11 by 33 kV transformer T, and here is the fault point. These two generator supplies power to this transformer 11 by 33 kV. A three-phase transmission line operating at 33 kV is connected to the generating station bus bar through a 5000 kVA step-up transformer having a reactance of 6%. It is 6%. The generating station has two alternators. One of 10,000 kVA and 10% reactance, and the other of 5,000 kVA and 7.5% reactance. Calculate the short circuit MVA for a fault between phases occurring at high voltage terminal of the transformer. The single line diagram of the system is shown in figure above. Assume the base kVA 10,000 kVA. Percentage reactance of alternator G1 at base kVA is equal to 10 into 10,000 divided by 10,000 is equal to 10%. Okay, next. Percentage reactance of alternator G2 at base kVA is equal to 7.5 into 10,000 divided by 5,000 is equal to 15%. Percentage reactance of transformer T at base kVA 6 into 10,000 divided by 5,000 is equal to 12%. The equivalent percentage reactance of the network percentage XE is equal to 10 into 15 divided by 10 plus 15. The two alternators are, as the two alternators are in parallel, G1 G2, this is the figure, plus 12%, plus 12 is equal to total 18%, the equivalent percentage reactance. So the short circuit MVA at fault point, at this fault point, 10,000 into 100 divided by 1000 into 18 is equal to 55.56 MVA. So short circuit current at fault point, as the voltage is 33 kV, 55.56 into 1000 divided by root 3 into 33, 972 ampere. Okay, thank you so much for watching the video. If you think the video is useful to you, then please subscribe my channel and share it to your friends. Okay, next I shall meet you in the part 4 of the circuit breaker. Okay, bye. Thank you.